Hello there, this is Ms. Nakayama, and today's lesson is 6.2, the Law of Cosines. In this lesson, we're going to talk about solving oblique triangles with the Law of Cosines, continuation of our previous lesson where we used the Law of Sines. We're going to solve some applied problems, and then we're going to use Heron's formula to find the area of a triangle. So, first and foremost, basically, you use the law of cosines when you don't have a pair. And that was what I said to y'all last time. When we use the law of sines, you have to have a pair. And when I say pair, I'm talking about an angle and a side that are opposite each other. We will use the law of cosines when you don't have a pair. And that's what SAS or SSS. So clearly, if I don't have an angle, I'm using the law of cosines. But let's look at what we've got. First off, law of cosines. These are variations of it. These two say the same thing, just talking about a different angle. But I wanted to show you how easy it is to remember it. And again, the best way to remember it is to write it down every time you do a problem. So if you remember the Pythagorean theorem, which we can't use on these triangles because they're not right triangles, this is very similar to it. C squared equals A squared plus B squared. And then if you remember the two sides that are over here, that's going to be minus 2 times those sides, and then the cosine of the other angle. And what's most important, that in each of these formulas, this right here is the pair. So whatever angle we're taking the cosine of, then this is going to be the side opposite that. And here it is in words if you like to remember it. I don't think it's as easy to remember in words as the law of sines is. So basically, they give you the steps of solving an SAS or an SSS triangle. But most importantly, whenever you use the law of cosines, the nice thing about it is you don't ever have to worry about two triangles. But you use it first, and then after that, you will have a pair. And so then we will continue to solve by using the law of sines. So look at this first example. We have a triangle that has angle A is 120 degrees. This is example 1. Angle A is 120 degrees. Side B is 7 and side C is 8. And that has been labeled here. Okay, so you can see we do not have a pair. We're going to round the lengths of the sides to the nearest tenth. Angle measures to the nearest degree. So we need to find little a, big B, and big C. So first and foremost, I'm finding little a because I'm given the side opposite angle A. So I'm going to write down a squared equals b squared plus c squared, because it's going to help me to write that formula down, minus 2bc cosine of A. And then I'm going to go fill in. Okay, A is what I'm looking for. B is 7. C is 8. And then I fill those in again. And my angle between those two, which is opposite the side I'm looking for, is 120. So you put that in your calculator, and you got to be really careful. One of the things you need to pay attention to is when you put this in, this is A squared. This is not A. So then you have to take the square root of both sides to find out that A is 13. Now, law of cosines is a longer formula, sometimes more complicated when you have to find an angle. So once we use the law of cosines first, it is much easier to go use the law of sines. So I'm going to set it up. I know that A, it doesn't matter which one. Oh, we come over here. A is 13. Okay, now I'm going to go find angle B. It does not matter which one you find first. So I'm looking for the angle. That means I'm going to put the sine of the angle on top, and B is across from 7, and the sine of 120, and it's across from 13. So we talked about this before, moving what's underneath my variable. So my 7 is going to move, and the sine of B is going to be equal to 7 times sine of 120 over 13. And I talked to y'all when we use the law of sines that whenever you're looking for the angle, okay, that's this button on your calculator, sine to -1. That's the inverse sine of all of that mess. And when you put it in, you're going to find that B is equal to 27.96. So we round that to 28. And then we find C by subtracting those two angles from 180. And so C is equal to 32. And we're done. Okay, if you have any questions about that, write them down so we can talk about them when you see me next. Okay, now, when you're not given an angle at all, you really, really want to remember when you use the law of cosines, given three sides, that you always want to find the longest side first. It will avoid your getting the wrong answer later on. Okay, so keep that in mind. Here we have A equals 8, B equals 10, and C equals 5. So I basically have to go find all the angles. I got to go find big A, big B, and big C. So which side is the biggest is 10. So that means I'm going to have B squared equal to A squared plus C squared minus 2AC times the cosine of B. So I'm going to go fill in. B is 10. A is 8. C is 5. 8, 5. And the cosine of B is what I'm looking for. So a lot of people mess this up. Y'all got to remember your order of operations. So in solving this, you cannot do anything with this yet. So I'm going to subtract both of these first. And again, y'all, I'm writing it out because I only want to pick up my calculator once. So 10 squared minus 8 squared minus 5 squared equals, and you can multiply 2 times 8 times 5, and that's negative 80 times the cosine of B. And then I divide by negative 80, so I'm going to have the cosine of B is equal to that. Now I'm going to pick up my calculator. I'm going to plug all that in. I'm looking for the angle, so I'm using the inverse cosine, and that's equal to B. And I find out that B is 97.9. So that's going to, of course, round to 98 degrees. Okay. Now, I'm going to go next and use my law of sines. Okay. I know I'm looking for the angle again, so it's going to be on top. And I knew that was going to happen. I wasn't paying attention. I did that before. Okay. Sine of 98 over 10. And y'all, you really probably should be using 97.9 right there. So be careful of that. Equals the sine of A over 8. What's under my variable is going to be move out in front. So I'm going to have A is equal to the inverse sine of 8 times the sine of 98 divided by 10. And we put that in, you get A equals 52.39. So that means that A is 52 degrees. And now I'm going to do 180 minus 52 minus 98 equals C. And we find out that C is equal to 30. And there we have solved our triangle. Okay, let's look at this word problem. Two airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other flies on a bearing of 75 degrees east of north at 350 miles per hour. How far apart will the planes be after 2 hours? So I have my picture, and let's just go with my horizontal here. I have one plane that flew directly north and one plane that flew 75 degrees east of north. Okay, so here's my 75 degrees. Okay, they're asking me how far apart the planes will be after 2 hours. So I'm basically looking for that side of my triangle. Now, you've got to know what is the length of this side right here. What is that distance and what is this distance? Okay, it's 400 miles per hour, y'all, but we want to know after 2 hours. So that's 400 miles per hour at 2 hours, which means that this is a distance of 800 miles. And down here, we have 350 miles an hour for 2 hours. So that length is 700 miles. So now I have two sides and the angle in between them. In other words, I do not have a pair. I'm looking for A. So I'm going to say that A squared equals B squared plus C squared minus 2BC cosine of A. And I'm going to fill in what I know. I don't know what A is. B is, it doesn't really matter, y'all. Either side, so it doesn't. So I'm going to say 800 and 700, fill those in accordingly. And of course, the angle in between them is 75 degrees. So you put that in your calculator and you come up with that lovely number. But remember, that's A squared. So that means that A is equal to 900. I didn't want that color. I want it in that color. Thank you. A is equal to 916.502, which means after 2 hours, the planes will be 917 miles apart. All right. Last thing we got to talk about, Heron's formula. Heron's formula is another way to calculate the area, and it's when you calculate the area of a triangle when you know the three sides. Okay, so here is our formula. And what you're doing, y'all, is you're finding S, which is the semi is 1/2 of its perimeter. So you add up all the sides and then take half of it. And then you take that number and you're going to subtract each side from that number and multiply them together. So let's look at this. Find the area of a triangle with A equals 6 meters, B equals 16 meters, and C equals 18 meters. Round your answer to the nearest square meter. So you've got the formula. Area equals S times S minus A times S minus B times S minus C. I got to go find S. So S is 1/2 of my perimeter. My perimeter is 6 plus 16 plus 18. So that's equal to 20. So I'm going to go over here and I'm going to put in 20. And then I'm going to say it's 20 minus 6, 20 minus 16, 20 minus 18. And if you want to go ahead and write, okay, well, 20 minus 6 is 14. And 20 minus 6 is 4. And 20 minus 2 is 8. That's fine also. Okay? So you write that, put it in your lovely calculator, 47.33. And so our answer, the area of our triangle is 47 square meters. And that's all we have. So I believe you have done all of this in geometry and algebra 2. So hopefully that was a quick review. Thank you so much for watching. And y'all have a great day.